Okay, hi everyone. So it's 14 o'clock point. So I'm glad to see that so many people of you are interested in security as well as in CI. So today's talk is about secretless identity management for CI systems, and what that means. I'm going to explain the next half an hour. So a little bit about me. My name is Jan Hicken. I'm a senior data architect at Otto Group DataWorks, which is a subsidiary of the Otto Group. Previously, I started studying at the University of Hamburg in 2011 and started studying information systems, which I've graduated with a master's degree in 2017. And already 1 year earlier, I started working at Otto Group DataWorks as a working student. And yeah, I did my master's thesis there, and I stayed there because I really liked it. I'm much in data engineering and software engineering topics. I'm working a lot with principles of DevOps. I'm into security stuff, and I'm also very interested in the whole technology landscape that results all about the Google Cloud infrastructure and stuff like that. When it comes to programming languages, I'm all about the JVM ecosystem. So I like Java, and I really like Scala, functional programming. So if you're into that, happy to have a talk afterwards. Well, CI. What do we really mean when I'm talking about CI? Well, most of the time when we are talking about CI, we are talking about these 3 steps here. So at first, linting, at which we mean typical stuff like static analysis of source code. And also, most of the time, enforcement of source code formatting stuff. So we want to make sure that everything is formatted correctly, especially, for example, if we want to check if a merge request is valid. Also, of course, for most of the languages that are compiled, we want to do a compilation in order to make sure that everything's correct, that we don't have any issues when, for example, updating dependencies or stuff like that. So that's also a crucial part of the whole process of continuous integration. And, well, of course, the most important thing is testing, right? So it's all about unit testing, and it's all about making sure that the software really does what it's intended to be doing, and also, making sure that it still does the things it should be after doing some changes. Well, there's continuous integration, but there also is continuous deployment. And we think of continuous deployment as something which includes the previous 3 steps from the continuous integration, as well as additional steps, which could be, for example, packaging your applications. For example, it could be building a Docker image, or it could be building an executable file that is kind of packaged to have an installer or something. And we also want to distribute that application to somewhere. So, for example, we want to distribute it to a Docker registry, or to some kind of storage or registry where people can download it and other people can use it to install it somewhere. And most importantly, when it comes to continuous deployment, of course, we want to deploy the software, right? So, for example, if we have an application, a microservice, we want to deploy that Docker image, for example, to a Kubernetes cluster, some serverless interfaces, or some VM. And before doing that, most of the time, people are relying on infrastructure as code, and infrastructure as code allows you to do something like a dry run, or something like a plan to make sure that really the changes you're going to introduce with that deployment is really, the thing you intended to do in the first place. So that's something that you need to do. And of course, the deployment itself. So creating, for example, infrastructure like databases, cloud storage buckets, creating new revisions of your software, and scaling it according to your needs. But when it comes to deployment, especially the latter 3 steps, normally require you to authenticate your continuously deployment workflow to some kind of service, right? So for example, if you want to deploy a Docker image, you need to authenticate yourself to the Docker registry hub, for example. Or you need to authenticate yourself to the Google Cloud, in this special case, in order to create a new revision, in order to authenticate yourself as a service account. So how does that even work? Small introduction for GCP is the easiest way is to just create a key pair, which is a public-private key pair. You get it mostly as a JSON file that's quite easy to do via CLI or the web interface. And you put that JSON file into your applications, or in this case, in your CI workflows file system. And afterwards, you just create an environment variable, which is called Google Application Credentials, and point that variable to the files, to the JSON key. So, yeah, it's like with Dr. Strange's timestone. That's easy. That works. I mean, it's really reliable to do. So, how do we integrate this within our CI systems? Well, most of the time, we use something which is built into most CI systems. So in this example, I've copied a screenshot from GitHub CI. We have something like a secret storage, right? So we have a special place where we can put these secrets, and we rely on the CI system that it makes sure that they're secured properly and that the access is properly controlled. And the most important thing is we don't wanna do too complex stuff in order to get access to the secret, which is quite easy in this case because you can just reference it. In this case, as you can see here, the deploy key is just something that is available as an environment variable in this case. We can just use it. In this case, it's just written to that file here, and then we can, in this case, we're using a make file. Hope that you can see it here. We just execute a make deploy that does the deployment internal stuff. That's not something we want to go deeper into. So I'd like to ask you, who of you uses these CI secrets for deploying stuff, for authenticating your CI pipeline? I see many hands. It's probably something. Yeah, if I would guess why, I would say that it's pretty easy, right? I mean, you just have to create the key, put it into the secret storage, and then reference it. So that's nice, right? So yeah, it's kind of nice, but deployment service accounts are by their very nature very privileged. So because these service accounts need to be able to do many things, like, for example, creating new infrastructure, deleting stuff, creating new revisions. So in practice, when someone takes over that service account, people could probably do anything to your whole environment, even your production environment, if that service account is privileged to do so. That means we need to make sure that these secrets are secured properly. So that means that we should probably answer some questions first when we want to grant access to these secrets. So first, maybe you want to do something like we want to limit the access to the secret by the repo. So for example, we could have maybe a few repos that just contain some libraries that are reused, and then another repo that actually does the deployment, and we want to maybe limit the access to that specific repo. But we can do better. You can maybe do something like limiting it to a specific branch. So for example, we could have some deployment service account that is used for deploying stuff in your production environment, and we could maybe limit that access to the main branch, for example. That's maybe something that is easy to achieve. But still, people, especially when you're doing trunk-based development, people are used to probably commit things directly to the main branch, and you probably don't want to have your intern that commits anything to your main branch access your most privileged keys. So that's definitely something that you need to think about. And there's stuff like this. I don't know if any one of you has ever seen this. So authentication is not always that easy, or maybe it doesn't even work all the time, and people are used to like debugging CI systems is not that easy as it would be locally, right? So here we can see that maybe the authentication doesn't work, it doesn't maybe do what we want it to, and people just do something like this. They print the deployment key to the log. Well, that's bad, because at that time the key is compromised. It leaked. And the unpleasant truth is keys leak easily. I mean, that's normal. That's a normal thing to do. We need to understand that it's perfectly normal that people do this, and we can do something like concealment, but still people will work around this. For example, GitHub Actions will prevent secrets from getting leaked, but people can't debug then because maybe they want to do it still, and they do something like base 64 encoding, and then the base 64 encode and secret isn't concealed, and stuff gets bad. So we need to just accept that this stuff happens all the time, and we need to maybe find some solutions. So what could be solutions for this? So in order to minimize the impact of such a compromised key, we should probably use keys that are short-lived. So we should maybe have a key that is maybe valid only a single day or just a few hours, so that even if a key is leaked, it can't be used afterwards. So that's probably something that we want to do. Well, if you do that, we need to rotate them manually, but that really doesn't make sense, right? So nobody wants to rotate every single key every day manually, so we need to do this in an automatic way. So we need to maybe automate this, script this, and have it run normally on a normally basis. And if you remember the previous slide, we also maybe want to do something like user-based access control. We want to make sure that some users are able to access the secret and some other users aren't able to do so. Not on a per repo, on a per branch basis, because it's really difficult to do so. And at that point, we can see that using static secrets inside some variable doesn't actually, using static secret doesn't meet any of those criteria. So at first we started okay, we want to just do some maybe Terraform apply or just some Docker push, and now we're here and we need to do all that stuff. Well, yeah, okay, let's see if we can do any better. Let's start with some minimum security requirements that we want to achieve. So that's the stuff I've talked about earlier. We want to have user-based access control, we want short-lived keys, and we want to have automatic key rotation. So that's the stuff we're now talking about that we want to achieve. And that's where Slim comes in place, a system we designed. We started with working on it in the beginning of 2019. And you can think of Slim as an external service for storing and managing these CI secrets that you need to have access to. So, yeah, but if you have an external system and you need to query that system in order to get your secrets, in order to get your CI and your CD workflows to work, you need to do two things. First, you need to authenticate that request that is coming from your continuous deployment workflow, and you also need to authorize it. So you need to, at first, make sure that the request really comes from the person that says it is coming from, and you need to make sure that that person is really allowed to do this. This is first authentication, then authorization. So we need to decide when that Slim server can hand out a secret, and especially, most important, when it cannot hand out the secret. So how do we normally authenticate ourselves? Passwords, right? So that means we need to introduce new secrets. Yeah, that's bad. So that doesn't actually solve any problem. How can we do this without integrating new secrets? We asked ourselves. Well, we thought that maybe we can use context. How does that work? Well, we use GitLab to run our CI system. So we have our wrappers at GitLab, and we also use the GitLab CI in order to run the jobs. That GitLab runs inside a Kubernetes cluster. And that Kubernetes cluster runs inside Google Cloud. So in contrast to like the typical zero trust architectures case, we do actually have some kind of context. And these services kind of are related to each other and know about each other. And you can use means of these services in order to validate that stuff is really working in the way that you're expecting it. So like Inception, this is kind of nested into each other, and of course, we need to go deeper in order to understand this. So how does that even work with looking at the context? Well, let's go really deep now. This is how a context can look like that's coming from GitLab. This is just a JSON document, and that JSON document actually contains some really valuable information that we need to have in order to make sure that the GitLab job is really a valid one. So at first, this here is a bunch of different Unix timestamps that is about when this document was created and in which time span it's valid. So we know when. We have something like this. We know which project the request originates from. So we can now see, okay, this is the repo. So we know that. We have something like the user's email, which is probably the most important information here because of user-based access, right? We know so we now know which user triggered the pipeline in the first place. So we know who. And also quite nice information here is we know which job the request originates from. So the job is the actual an ID that identifies the single CI run of maybe that has been created after a commit has been done. and pushed. So we know which job as well. And the most important thing, of course, is when you're thinking about authentication, we have a digital signature on this. So we can use public key infrastructure and public key cryptography in order to make sure that this document hasn't been spoofed by anyone. I mean, anyone can create that JSON and just assume he is someone he isn't. But there is a digital signature from the CI system of GitLab that can make sure that stuff is all right. In a similar fashion, remember we are having different levels of context. We have a similar document that originates from Google, from the Google Cloud. And that looks kind of similar, but contains varying information that is also kind of interesting. First, we also have an email address. This is not the email address of the user, but the email address of a service account which runs the VM on which the job is running on. So we have some kind of identity as well. We also have timestamps, so we know when this document has been created, or in this case, EXP stands for expiry. When does this information expire? When isn't? When's the point when it's no longer valid? And most importantly, we have information about the actual machine that this job is currently running on. So we have something like instance IDs and zones and stuff like this. That's probably normal to anyone who's used to cloud environments. So we know which instance. And also, as with GitLab, we have a digital signature. So we can make sure if we know the public key of Google infrastructure, we can make sure that this document is really valid one and hasn't been spoofed. So how does that work in practice when we talk about SLIM? How can we now work with that context to make use of it? Well, as I've explained, we can think of SLIM as some kind of external system that contains all the secret we want, and now SLIM needs to decide whether to hand out the secret or not. Well, we can fetch the public key of GitLab in order to make sure the document is valid. We can then ask the GitLab API, because we know the job ID, if that's really a valid job, if that job is really currently running, and if it's a known job, so we can really make sure that stuff is all right. The same is true for Google. We can fetch its public key, we can validate the document, and we can also ask Google's APIs, for example, the Compute Engine API, in order to make sure that the instance is a known instance, so we maybe know the instances our CI systems are running on, and we can now validate if everything's correct. And we can also validate that the service account the instance runs with is not something that is surprising to us. And most importantly, when we're talking about user-based access control, we can ask a lot of questions about the user and the environment and about the wrapper. We can maybe ask if the user that triggered the pipeline is a known user and has the correct access permissions. So maybe we have some kind of database, which I've called here directory, which contains some information. We can make sense of group memberships and permissions and stuff to make sure that the user is authorized to gain access to the secret. So how does that integrate with our CI or CD job? Well, it's quite simple. It fetches that document, the JSON file, from GitLab. That's really easy because it's already supplied automatically by GitLab as an environment variable. So that's really easy to do. Second, it also fetches the document from the Google server. And it sends over these documents to the SLIM server in order to first authenticate and authorize it. So we don't have any passwords. We don't have any keys or secrets involved here. It's just a publicly available document that is available to that CI job. It doesn't contain any secrets. You can just send it over the line. And then we can, the SLIM server can do the previous steps from the previous slides in order to make sure everything's all right, and if so, can hand out the secret. Well, I don't know what you think now, but that looks like a typical Passierschein 38 problem to me, because it's not that simple. Because integration is probably something that is if you need to fetch all these documents every single time for every CI job, that's probably not something that's practical to do. That's why we decided to make that easy. This is a typical example of a CI pipeline, as explained earlier. So we have some kind of statement. The first script is just moving the secret from the deploy key variable to that file. And the second one is doing the deployment. And now what's different is we're not using the environment variable anymore, but we're using something which we call SLIM client. And that Slim client does all the steps, like fetching the documents, sending them over, and getting the key. And you can even do something like this. You can actually say which service account do you want to fetch the key for. So which service account do you want to impersonate here? So as you see here, we are fetching credentials for a deployment service account for our dev project, so development environment. We can just exchange that value for the prod environment, and we get another key. So this scales quite nicely. We don't have to do much on the client side in order to use different secrets for different environments. And this client is now pre-installed to all our GitLab runners. So it's anyone who is working in our department can now just use that line, can exchange the previous printf statement with the Slim client one, and that's it. So really easy to do now. And people are actually preferring the Slim client one to the old one because they don't have to manage or create the secrets in the first place. It's just done by the Slim server automatically. So if we look back at our security minimum requirements, we now have user-based access control, yay, because we can now use the Slim server and all its mechanisms to make sure that the request is properly authorized. Nice. But we still have short-lived keys and automatic key rotation as a problem. That's not something that we solved. But we now have a Slim server that is responsible of, like we have a single instance that should feel responsible for it. So we can now assign that responsibility to the Slim server. So to be honest, I've omitted something in the top right there. The metadata document actually comes from the Identity and Access Management API within Google Cloud. Not something that's really important here, but the secrets also just don't come from the Slim server itself, but are stored inside the Secret Manager API, which is like a managed service by Google, which you can use to store secrets in a secure fashion. And now, because the secrets are managed inside the Secret Manager, Slim can also make sure that the keys are rotated daily on a daily basis. So, and also the old ones are revoked automatically. So this is something that's now really easy to implement because Slim has just a list of known service accounts that are possible to impersonate by the CI systems, and then it just does that automatically for all the service accounts on a daily basis, or manually if you really fucked up and compromised something, you can just push a button and have the key rotated. So let's have a look back at our security minimum requirements. We now have user-based access control, we have shuffled keys, and we also have automatic key rotation. Oh, yay. And we don't have to do much in order to migrate our workflows, so that the users of Slim don't have to do much in order to migrate their workflows. So let's have a look at, small conclusion now. We have no static secrets anymore on our CI. So the secret storage, the screenshot I showed you in the beginning is now just completely empty. We have no static secrets anymore. We have user-based access control, automatic key rotation, and we have also a property which is nice because it's scaling quite nicely with the growing number of GCP projects we have, because every GCP project has a dedicated account that is used for deployment, and then now we can create keys automatically. We just have to extend the list that Slim uses to manage. We have easy integration, as seen before. We just have to exchange a single line of code in the CI workflows. And this is actually in productive use since 2019 right now at Autogroup DataWorks. So this is not something that is a theoretical use case or something that is kind of like a new idea, but we're actually using it for 3 whole years now, and it's working nicely. Yeah, kinda. Well, every time you introduce something new, there's also pros and cons. And a few cons we have is there's yet another service that we need to maintain. Because, that's just something that needs to run. It needs to be patched, and it's very secure. We need to patch it. And it's also a single source of failure for all the CI pipelines, right? So if Slim is down now, you can't fetch any secret, and that means you can't deploy. Not a single team can deploy anymore. So that's really something that's kind of bad. And also something that is maybe a little problematic is that the Slim service has now complete control over the complete whole environment of whole GCP, because it just has control over all the deployment service accounts for every single project. And these are very privileged, and most of the time have owner permissions on GCP and can do everything. So you may ask yourself maybe now, is there something we can do better? Yeah, we improved that. last year, Google announced a feature in the Google Cloud platform which is called Workload Identity Federation. Well, that sounds cryptic. What does that even mean? Well, let's jump right into the target infrastructure on what it looks now. Well, this is the current setup of Slim 2.0 and looks kind of familiar. There's now only a single document anymore, and where Slim previously were, we now have the Workload Identity Federation. And instead of returning a key, we now have a short-lived token that automatically expires after some time, maybe 10 minutes or an hour or something. Yeah, you're asking probably yourself, what black magic is this? Well, it kind of works similar to Slim. Well, it still fetches a public key from GitLab in order to make sure that the document is okay. And it still makes sure that the permissions are correct, so the user is nice and the repo is okay. But the permissions are actually stored inside the Identity and Access Management API. And we need to populate that somehow. We need to make sure that Google knows about who can access what and what not. So we create a deployment from our directory to the IAM API. Well, it still is a little cryptic, right? So let's have a look at the concrete implementation here. Well, this is still the example from the document from GitLab, just a little narrowed down to the important information here. And what we do now is we configure the Workload Identity Federation feature from Google to do a mapping between the stuff we had at the document and the stuff that is used by Google internally in order to make sure that the authorization works. So in this case, we are doing. We have something like the user's email, and this mapping maybe says that the user's email here is fetched from the document above and can now used down below inside some specification. This looks like a URL, but it says, okay, this user, myuserexample.com from GitLab can be now bound to some resource. It can now say, okay, this user from GitLab can now do stuff inside GCP. So this is just a mapping of permissions from GitLab to GCP. And we can also do something like mapping attributes. So we can map, for example, the repo's name or the group name of some repo in GitLab. And this is, in this case, it's mapping the namespace from the group to some kind of principal that is known to Google. This principal can then be bound to some specific permissions and can be checked. So how does that integrate to GitLab? Well, it's kind of the same now. Well, you may ask yourself now, well, are we back to using deploy key variables? Well, kind of. The deploy key variable now doesn't contain any secret anymore, but just configuration. The deploy key variable contains some stuff like, okay, which the Workload Identity Federation endpoint do we want to use? What's the file where we can find the document for like the one with the signature? And where do we actually want to, that has been pre-filled, like has to be sourced from somewhere. And we can also make sure that we impersonate the correct service account here. So in this case, the deploy key isn't a key anymore, but just configuration. And that even means that we can store it inside Git because it doesn't contain any secrets anymore. So like the deployment, so the authentication configuration that we can use, and it's built into the Google authentication clients automatically, is now, it's a seamless integration. You just have to write that configuration, deploy the permissions, and that's it. No secrets anywhere. Not on the client, not on the server. So when we look back at the security minimum requirements, we now have user-based access control still, but we don't have any keys, so we don't need to rotate them, but instead we have short-lived access token, which is even nicer. To go a little further even, we can now, this is a screenshot from the organization policy UI of Google, where you can just define some stuff that people can and can't do. And we actually were able to disable the permission to create service account keys in the first place for all projects we're using. So there's not a single JSON key in place anywhere in the complete infrastructure. And this is really nice because we don't have to make sure that they can't leak anymore because there isn't the possibility to create something. It's just been completely replaced with the impersonation of Workload Identity Federation. So let's have a final conclusion. We don't have any secrets anymore, just config. We have user-based access control. We have short-lived tokens, and it scales. It scales well because we just need to create the permission setup inside Google. And we also not just scale well with the number of projects, but also with a number of accounts. Well, we just need to create a real big set of permissions that we want to integrate. We have still easy integration. Well, we have just to integrate 2 lines of code. And we can do that in a scripted fashion. The permission setup can be scripted quite easily. We have no runtime that we need to patch, that we need to make sure it runs. We have no single point of failure. We don't need to monitor it. And also we have no central service anymore with God permissions. That is kind of problematic before. So yeah, that's about Slim. I can just say it was a nice ride going from 2019, developing our own service and then migrating to the Google-provided stuff that is really similar to our own developed solution, and can now make sure that we don't have any secrets in place anymore. So thank you. You can meet us at the Otto Group booth, and on the I think it's on the first level. And by the way, we're also hiring, so if you're interested in data engineering or cloud engineering or data scientists, then just talk to us. And I'd like to end the session with Q&A.